Hello guys, welcome to expansion of x. Yes, just x. The variable that we all use, just x. So, I've given you guys some hint on how to really expand this. So first, I saw my blank at the part. It was awkward. So it's x. And here, I've given the dimensional formula, ml squared to the power minus 3. Which, this is the dimensional formula of power. And also, so here, I've told you to apply the power here, or to apply this over here. So you have ex. Well, when you apply the power, it becomes e to the power x. So thus e to the power x. And over here, there are many blank in this forest who chop them up. Now, in the thumbnail, I've given apply over here. So there are many blank in this forest who chop them up. So it should be logs. I know it isn't that obvious, but it is what it is. And not just any log, the log natural. And we have e to the power x. So to apply this over here to the power, you just simply have to put this instead of x. So you'll get e to the power ln x. And when e and ln are together, they cancel each other, giving x, because they are inverse function. E to the power x and ln x are inverse function. So when they're together, they just give x back. Now, so we see we have our x over here, which came from e to the power ln x, which in turn came from putting ln x instead of e to the power x. So meaning that we just have to find the expansion of e to the power x first. So before that, we need to find what e is, the definition of e. We have to use that. It is defined as a number approaching infinity, 1 plus 1 by n to the power n. That is defined as e. Now e to the power x, you just have to raise the power of both sides to x, like so. But here, when you raise the limit to power x, it really doesn't mean anything. So this power just applies to this over here. Now, if you want to expand this, you have to look at each of the terms. Limit, expansion, what the hell does that mean? But what about expanding 1 plus 1 by n to the power nx? We can, because this is a binomial expression. And thanks to the binomial theorem, we can expand this and hence get the expansion for e to the power x. So let's see what the binomial theorem says. So let's say you have 1 plus x to the power n. You can, its expansion is 1 plus nx plus n minus 1 by, this would be 1 factorial, by 2 factorial x squared plus n minus 1 n minus 2 x cubed by 3 factorial, and in fact this goes on forever. So this is the expansion, it goes on forever, and here we just have to apply this to here. So 1 plus 1 by n to the power nx. So here n is of course the power and x is of course the second term. So 1 plus nx, n is the power, so nx into the term 1 by n by 1 factorial plus nx minus 1 into x square, which is 1 by n square by 2 factorial plus so on, right? Now, we have just expanded this, or we have just found the expansion for this. But as you can see, e to the power x, the n has to approach infinity. That means at some point, we have to put the limit as n goes to infinity over here. So, as you can see, for this one, n and n cancels, but here, you have just n and 1 by n square. So, of course, the square and n cancels, giving us n in the denominator, but in the bracket over here, we also have n. And when you put infinity, it becomes infinity minus 1, which is infinity, but on the bottom you'll also have infinity. So you'll have infinity by infinity, which is indeterminate. That means it is necessary to cancel all of the n's on the denominator at least, or from the numerator, or both if we can. So you can see from the bracket we have n. So let's just take that common, because then you'll have n square and that n square will cancel. Well, you can just simply take n common. So you'll have n into n square, x minus 1 by n. And this n square and that n square cancel, like I said earlier, so we don't really have to write that, by 2 factorial. Plus, we can see the pattern, x minus 1, x minus 2 by n by 3 factorial. So on and so on, right? So, in this step, we can actually put the limit, because, well, we have to find e to the power x. So, little congested, but it's okay. Now, we know this part is just e to the power x. And let's apply the limit. This applies to all of it. So, it's just 1 plus x by 1 factorial, since there is no n. Plus, when we apply n over here, it becomes 1 by 0. Sorry, 1 by infinity, which is equals to 0. So x into x basically, right? So that's just x squared by 2 factorial plus x into x, because they're all 0. In fact, 1 by n, 2 by n, 5 by n, all are 0 when, well, n approaches infinity. And x will multiply that many number of times. So x cubed by 3 factorial plus so on, so on. Now, don't forget we have to expand x. And we have to do this step over here, where instead of x we put ln x. So we have e to the power ln x is equals to 1 plus, instead of x just put ln x by 1 factorial plus ln square x by 2 factorial plus ln cube x by 3 factorial, and so on. Finally, from here we get x is equals to 1 plus ln x by 1 factorial plus ln square x by 2 factorial plus ln cube x by 3 factorial, so on. And that is our expansion of just x. And if you want to verify, you can just put x equals to 1 and put x equals to e, because here e to the power 1. So e to the power 1, everywhere instead of x just put 1, and 1 to any power is just 1. So e will be equals to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial, and so on. That is the expansion of just e. And well, that is it. If you learned something new, please like and subscribe. Thank you.